Welcome back everyone to lesson 2 of the Vectorworks 2013 2A design series. I'm James Russell. Today we're going to have a look at some of the more advanced 2D things that you can do in Vectorworks that also start to relate to 3D objects, and as well as that we're going to touch base on the 3D world, some basic 3D stuff and navigation around the 3D world, which are core things in terms of moving you guys forwards into the 3D world and therefore forwards in your design. So, we're going to start straight out here and we're going to have a look at the modify menu. And there's a few commands up here that we just really want to focus on. It's mainly these first 5 up here. So I'm going to try and run through them all and give you an example that goes with each one. In the past we know that using our rectangle tool we can just draw a rectangle, and feel free to just follow along here. I'm going to draw this one by double clicking on the rectangle tool and choosing a height and width. Let's go with 100 in width and 200 in height. And I'm going to choose position and next click. Actually I'm going to change that up. I'm going to take that off, choose the top left hand corner, and in here I'm just going to pop in a 0 and a 0. So everyone's got that. Going to click OK, and it'll place it there somewhere on my page, and you can see that the top left hand corner here is lined up with 0 and 0. Now in the past we've had a look at this and we've moved our objects by going over here to the object info panel, and using this little box here we've chosen a corner which has referenced this, and we're able to move objects. So just to reiterate that, if I wanted to move this across the page in the X, which we think is across here, I would type in say 100, and by pressing enter it would move it 100 across in the X direction. But it's not actually that, it's actually a coordinate system here in this box here. It means it's moving it from the 0 point to the 100 point. If I type in 50 in here, it's going to move to X50. And similarly in the Y, if I type in negative 50, it's going to move down to negative 50. If I type in 50 in here, it's going to move up to 50. There is another way to move objects though, and let's just say that I drag this and put it over here, which is completely random. If I drop down the modify menu and go to move, I get 2 commands up here. One is move, and one's move 3D. And quite simply, one is the 2D version of move, and one is the 3D version of move. I'm going to choose move here, which I can also get by Control M or Apple key M for you guys. And up here we get the move selection box. Now there's 2 different ways of moving things here. We can either do an X and Y offset, and we can do the polar offset. Now this here is very similar to X delta or X plus and Y, plus and minus, which means a change in X. So it doesn't take a point relative to our current grid, it just moves it by an amount. So let's say I did just want to move this by 5 and 0 in here. So it's moving just from its current position across 5. Hitting OK, you'll see it has just jumped a little bit there. Now we can also use this in the polar form. If I go here to the modify menu and under move again choose polar, you can see here I've typed in some values, distance of 100, and let's do an angle of 0. Now in the Vectorworks world, 0 is actually to your right hand side, not pointing north as you'd normally expect. You can change that in the preferences, but that's just how it works here. And we're going to do a distance of 100, which means at the angle of 0, it should move 100 across. To give you another example of the polar moving system, if I wanted to move something 45 degrees, meaning up to my top right hand side, I type in 45 degrees here for the angle and 100, it should move upwards towards my right. And there it goes. Now this is really handy if all of a sudden you've just dragged a couple of components around and you need them to be separated from each other. Here's an example here. Without really caring about what's here on my right hand side, I'd just like these 2 objects to be, I don't know, 10 millimeters apart. Modify, move again. I'm going to use the Cartesian plane. And I'm going to type in 10 in my X offset and 0 in my Y offset, which means I want it to move 10 across from its current position. By clicking OK, you can see it's made a nice gap in there, and if we were to measure that gap there, we'd find out it's 10. So that's great for spacing items and really important for getting really detailed drawings done. Moving right along, we're going to look at the send command. And the send command you might have encountered already just in venturing in your 2D commands, but here I'm just going to resize these boxes and overlap them. You can see that this one, because it was drawn last, is currently sitting on top. That's fine for me at the moment, but let's say I want to move it through. I'm also going to add a 3rd object in here just so we get a full spectrum of what's going on. So I've got 3 items here. This was drawn most recently, this second most recently, and this was the last thing to be, or the first thing to be drawn last in our current series. Let's say I just want to bring this to the front. It's quite simple. Modify, send to front. There we go. It's popped in front of all those other objects. Now you can also access all of these by right-clicking on the object, choosing the send command, and all of them are here. So send to front, obviously bring it to the foremost. Send forward means it steps one object forward within your current layers. Send to back, obviously just throw it all the way to the back, and send backwards. And here I'll show you using Control Alt B for me. I'm going to send this object backwards, and it should just go one layer back. Control Alt B. You can see it's moved one object back, but it hasn't gone all the way to the back. If I hit it again, it would end up all the way at the back. So in working in the 2D world, that's how you really want to just be juggling your objects, because in the 2D world there really isn't a depth as such. This is your depth, but they're all sitting on the 0 plane in terms of depth. We'll get into that more when we talk about 3D objects. So from our modify menu, the next one down is align. And here's what I'm going to do. I'm going to grab a whole heap of small boxes here. And we're going to play with the align function. Maybe one more just in there. Great. So the align and distribute function, it's pretty simple and straightforward to use, and it comes with a really handy GUI. That's a graphical user interface for those of you who aren't computer based. Under the align menu here, there's a couple of options. Align to grid, which means basically snap to one of my current grid settings. Align distribute 3D, and align distribute with the leader lines. We're going to focus on the middle two here, align distribute and align distribute 3D. Obviously one is 2D component based and one is 3D component based. We're going to choose the align distribute option here, and it comes up with this, and it's really simple. It works in 2 ways, the up and downward side and the acrossward side. That's all you need to think about, up and down and across. We're going to play with align first. So in this instance I want to align to the top, and you can see all of my objects here move. So I'm going to choose align top, which means all the tops of these objects should all come to the same line, and it will come to the topmost object. So in this case it's probably this rectangle here. Clicking OK, you'll see that they'll all align to the top, and all of those top sections there, if I draw a line across, are perfectly in line. So that works quite similarly. You can also do centers, which is a great option. So I'm going to choose align distribute to center instead, and you can see that all the centers should be aligned, so they'll all probably align to this, the tallest object. Hit OK there, and you can see they're all got the same center line now. Now similarly you can do that on the other axes just by checking the different align box. So if I'd gone align and align distribute here, and instead of this align I'd chosen this align, you can see a similar thing happens just across the side. But instead I'm going to choose the distribute command, and what this does is distribute evenly between the first and the last object all of the other objects. So here for example I'm going to choose center, and that means the center of each of these objects should be evenly distributed between all of these. So watch as I click OK, and you can see that it's placed the center evenly in 6 different parts here. Now this works well, except for if you have one object that's larger than the rest. So here I'm going to do the same thing. I've made that box slightly wider. From the align menu, choose align distribute, and do it again. Now let's say I want this gap here and this gap here to be equal, and this gap and this gap and this gap, so there's an even space between all of my objects, as opposed to there being even centers of each of the objects. That's easily done. Just drop down the align menu, go to align distribute, and instead choose spacing, which ensures that, as it says, the space between the objects is equal on the left and right hand sides of the objects. Hitting OK, and there we go. And we know that that space there, if I draw a box for example, in this space here, which has actually just turned out to be a line, it'll be the same as this one here, and the same as this one here. Now that's really handy for aligning objects to, say, the edge of something. Let's just say that we had one primary object right here, and we draw on a whole heap of objects that we wanted to align to it. As opposed to having to click and drag each of those in and snap them in, I can just select them all, ensuring that one of them is in the correct position, and just going here, once again, align distribute, align to the left hand side, and there we go. They're all sitting now nicely on that line. The last one here from the modify menu that we're going to play with is the rotate tool, and obviously we've already played with rotate in one of its forms. This one here is more of a number-based rotation. And just going modify here with one object selected. I'm going to choose rotate. And there's two options, rotate and rotate 3D. And then a couple of logical ones here, rotate left 90 degrees, rotate right 90 degrees, flipping on the horizontal and flipping on the vertical. Now I'm going to leave those ones to you, but I'm just going to use the rotate command here. And it simply asks what is the angle of rotation, disregarding what is currently here written as rotation. So it rotates in addition to whatever you have here, and this number will change. So as an example, if we had 45 degrees here, and we typed in 5 degrees here, this will not rotate to 5 degrees, it will rotate to 50 degrees. So it's in addition or subtraction from the current angle. So I'm going to type in 5 here, and you can see I've slightly nudged this to 5 degrees rotation. There's one more, just briefly up here in the modify menu, is scale objects. And this works in 3 different ways. The main one that you'll probably use is the symmetric, unless you're doing it by distance or you'd like to do a scaling factor, and a couple of checkboxes. So explain what this is. Symmetrical means that it scales in all forms. The X meaning across, the Y meaning up and down, and the Z meaning depth-wise, which we haven't got to yet. So a symmetrical factor of 2, for example, will make this object grow 2 times its current size. Hitting OK, you can see it's grown to twice its original size. Similarly, if I'd gone scale objects and done 0.5, it should halve the current size of all of those factors. Hitting OK, you can see it's back down to its original size now. So just to show the other modes here of the scale objects command, I'm just going to draw another little box here, just so I've got a rectangle back. So scale objects here, there's the second one here, sorry, the symmetrical by distance. This allows you to put in one current value and a new current value to replace it with and scale by. So for example, we could type in 1 and 4 in here, which means obviously it's timesing by 4 to achieve that value. Or if you don't want to do the math, you can type in some strange numbers, such as what I've got here, and Vectorworks will do the calculation for you, making this distance here equal to this distance here, and scaling everything else proportionally according to that. Also got the asymmetrical here, and what you've noticed here is that you've got an X scaling factor and a Y scaling factor. And basically in this scenario here, my X scaling, or across, I want to times by 2, but in my Y scaling, I'd like to half. So it's kind of like a double, doing 2 operations at once here. And by clicking OK, you can see this box has become twice as wide and half as high. So that's kind of handy to have going on. It's also changed the ratio here if you have a look over on the side. There's a few other modifiers. At the bottom of that menu you've got scale text, so you can decheck or check that depending if you'd like to keep your text size the same or proportional, and you can do it to the entire drawing as well. So if you've mucked up your scale somewhere along the line, if you've accidentally left your scale in inches and need to go across and it's like 47.5 versus 50 to scale or something like that, you can always scale your entire drawing through there. It is quite risky and you really want to be confident when you're doing that. This is the end of the 2D Basics component for this module. We're now going to do an exercise called Everyday Objects. This year, to mix it up, we're going to choose something from your kitchen. You're also going to need a ruler for this exercise. We're going to draw the object that you choose from your kitchen in 2D, looking at it from the front, the side, and the top. But most importantly, it's got to be to scale. That's the most important part. You should spend about 15 minutes trying to do this, putting as much detail in as you think appropriate. Good luck! So this is the really important part of the lesson, and probably one of the most important parts of the series. This is where we make the transition between the 2D world and the 3D world. And it's a vital step, because if you miss something in this next couple of minutes, it might ruin you for a while for the next couple of episodes. So make sure you pay attention, go back if you need to, watch some more, watch it again, and ask questions if you need to at this stage here, because there's some vital things in this that you really need to focus on. So I'm going to clear our working space here, and I'm going to draw 3 objects just to familiarise ourselves here where we are at the moment. I'm just going to draw a nice long rectangle across here. Going to draw a circle somewhere along the line here, that's pretty good there. And I'm going to draw another shape. I'm going to choose a pentagon, and I'm going to place it just here. There we go. Now what I'm going to do now is the first operation of the 3D world that you should probably be touching, and that's called extrusion. Extrusion is when you take a 2D object, for example this box, and you pop it out of the page. And what I mean is you just imagine that rectangle right there in front of you coming out, getting depth and coming towards you at a certain height. So that's what we're going to do. You go to your model menu up here and you choose extrude. It can be accessed with Control E for me or Apple key E for you guys. If you click on extrude, it asks you one thing: what is the extrusion height? In here I'm going to choose a number, let's just say 50. Try and keep it proportional. You can see these two values here. I've got 300 and something and around 50. I'm going to make my extrusion height 50 as well and see what happens. What you'll notice is this has gone clear, and it's also got a new heading up here. It's now called an extrude. All those other values that were there associated with the rectangle are gone, and we've just got two other fields here, extrude and bot Z. And we're going to deal with those in a second, but what I'm going to do is just alter these as well. So I'm going to do the same thing, model, extrude. Let's give this one a height of 150, and this one here, the polygon, which is actually a pentagon, I'm going to extrude that out to let's say 220. Now that's just proportional to your values, so you should have a low one, a middle one, and a higher one. What we're going to do right now is talk about the numpad on the, it's in the right hand side of your keyboard if you're working with a keyboard. If you're working on a laptop you probably won't have one, so I'll show you the other method. Those of you who have a numpad on your keyboard, hit the 3 key. Otherwise, if you're working on a laptop, drop down here where it says current view top plan and choose the right isometric. Now you might have to zoom out or move your page around, which is just done with the spacebar, but I just want you to hold at this point here, and you can see on my drawing I've got these three objects. I've got what was a rectangle, which is now a rectangular prism. I've got this, which is a cylinder made out of our circle, and I've got this, which is our pentagon extruded out into a prism. And you can see it's simply taken those shapes there and given them some height. Okay? You'll also notice about this is it's changed from our grid pattern that we had before. That grid is still represented here, the 2D grid shown by this blue checkerboard pattern, which is in the center of the screen right now. But you'll also notice these extension lines. A dashed red line heading into a dashed solid, a dashed green line heading into a solid green line there, and a dashed blue line heading into a blue solid. These represent the X, Y, and Z axes, and they work in the same order of R, G, B, which are our three primary colors. So we've got X is the red, Y is the green, and Z is the blue. Okay? And they also work in this. If you think of these dashes not as dashes, and this is how I like to remember it, as little minus signs, these are all the negative directions. So negative X, negative Y, and negative Z. And that'll really try and help you in the future in moving these objects around in this plane. We're going to take a brief moment to talk about the numpad with a little exercise. This image here is of a flattened cube. It's similar to something that you might have seen at around your grade 3 in primary school, where you'd cut out the shape, fold it up, and it'd make a cube. This is the same thing. It's just slightly different for these purposes. What you need to do is find this image in the video description below, or if you've been given a handout you can use that as well. Cut it out with a pair of scissors all the way around the outside, so you're just left with the shape. Once you've done that, I want you to find the tab highlighted here in red. Get rid of it. We don't need it for this exercise. So what you should be left with when we finish this is a box with no bottom. What you then need to do is fold along these green lines. And then also these green lines. You should have crease lines running horizontally and vertically now. What you can then do is fold these four corners in, and you should have a cube sitting in your hand with no bottom. Once you've done that, unfold the cube and write the word top in the center right here, and also the word front on the front side. So you should be able to fold this back up again, have the top labeled and the front labeled. You can go ahead and do this for the rest of it as well, left hand side, right hand side, and back as shown here. Let's step away from the box for a second and focus on the keyboard. What you can see here is the numpad shown on screen. What you'll notice is there's the numbers 1 through 9 and the 0 key. What we're going to do is look at our object that we've got, the box laid out flat, and place it so it's centered on the 5 key. And what you'll notice is that the top lines up with the 5 key. Similarly, the front, back, left and right line up with the 2, 8, 4 and 6 keys respectively. Believe it or not, if you pressed any of these keys in Vectorworks, they would associate to those labels that we've put on our box. if you break this down even further, if you combine the sides of front and right, where the corners are, the little kind of triangular joins, and labelled them as front right, back left, and front left, you'd end up with the isometric patterns, as if you were looking at those from those perspectives. So labelling those up, you can see that we hit the 1, 3, 7 and 9 keys, and end up with our isometric views as well. Finish labelling up your box, and have a play with these. Coming back to our 3D world here, I've still got my 3 objects, and I want to discuss some of the properties of 3D objects, and then run through the 3D menus. I'm just going to select this cylinder here that we've created from this circle, and we've brought it up out of the ground using the Extrude feature. Over here you can see it's got a couple of different modifiers, and it's no longer considered a circle. You have to think of this more as a rectangular prism or a box. So it's got a change in X and a change in Y, meaning a change in X, represented here by the red, and a change in Y, represented here by the green. It also has the extrusion height that we've made it, the radius of this circle in this case, and the bot Z value, which we'll talk about in a moment. In the extrusion height here, I can just simply make this taller. For example, typing in 200 becomes taller, or much shorter, say 50. There we go. You can also alter these values and the radius value, but bot Z's an interesting one. And to do it, I'm going to hit my 2 key and move to a front view, where you can see all 3 of these objects, having been brought up from the 0 ground plane here, from the 2D world that is, they all sit on the 0, right here, on 0Z. Now what you can do, if you'd like, is just move this up. So what's the size of this box? It's currently extruded to 50. I'm going to highlight my object here, and I'm going to move its bot Z up to 50. And you can see it's moved up on top of this object that we've created, and it's now sitting floating. If I have a look at here in a different perspective, I can try and have a look. But we all know it's floating now. Now, as you can see then, I couldn't quite see what I'd like to see out of the different perspective views that I've got here. Jumping back into a top view, hitting the 5 key, I'm going to show you how to use the flyover tool, which is something we skipped over in the basic tool set. By clicking on the flyover tool and getting this handy reminder here, you can set it to a couple of different options. Leave it for the moment on the interactive origin mode. This is how the flyover tool works. When in interactive origin, left clicking once will set the origin. You can see it indicated here by a kind of black dashed line representing a crosshair. By left clicking, for example on the center of this cylinder, it moves the black crosshair to be here. Then, by clicking and holding down your left mouse button and dragging either up or down, left or right, you can rotate around the fixed point that you've created. As you can see, now I can fully see if my cylinder is floating, which indeed it is, off the ground, or not. At any time you can let go, it'll stay in this kind of view here, and you can left click again, relocating your origin, and choosing that as the new rotation point from which to work around. It does take a bit of getting used to, and you don't want to make rash movements, otherwise you'll end up flying all over the place and it'll just become a chaotic mess upside down. Just remember that all of these isometric views are not ideal for drafting in. You don't want to be doing edits in this unless you're really confident about what you're doing. You want to be doing it from your top view, your front view, your left or your right or your back. And at any point in time you can hit the 0 key, which takes us back to the 2D world with these 3D shapes represented as 2D. It's called the top plan view from up here in your top menu. Now we're going to have a look at the 3D menu. It's down here, it's called 3D modeling. It's got a cube, a cone and a sphere, and sometimes it'll have the text written to it depending on how you've got this showing up. By clicking on that we get a tool set here, which is the 3D tool set. I'm going to quickly run through all of the things inside it as best I can. The flyover tool is represented here as well as in the basic tool set, just mainly so you don't have to keep flicking between the 3D and the 2D world. It's just ease of access up here. Setting the working plane is something new to 2011 series onwards, and we'll talk about it when we get to some angled planes which we don't yet have. But basically it moves the standard 2D plane and relocates it onto a different angle. The push-pull tool is something new to the 2011-2012 series and onwards, and it's a really great tool, kind of melding in with the SketchUp series of design. What we're going to do here is place a box down, a rectangle, onto our surface here, There we go. And we're going to look at that in the isometric world. And you can see that that's represented here on our ground plane as a 2D object. Still here is a rectangle as well. Grabbing the push-pull tool, I can actually grab this surface and lift it up off the plane. You can see it's just growing out of the ground here. It's much like the extrude, and in the old days we used to have to extrude everything. Now with the push-pull tool you can simply grab an object and lift it up out of the ground. Similarly, you can also grab other objects and surfaces and extrude them. For example, I could make this cylinder taller just by grabbing the surface and pulling it up, make this object longer, or even pull things on a strange angle. The push-pull tool is a great innovation, and you should pay a lot of attention to it in the future, as it's probably going to be the future of drafting following the SketchUp model. The 3D loci doesn't have a purpose to you guys at the moment. It does come in handy when you're trying to plot surfaces out, when you're trying to do 3D points across a grid reference, but for the time being it's not really necessary to you guys, so we're going to leave it alone. The 3D polygon is much like the 2D polygon and polyline tool. It's able to create a shape. The only difference is that this surface has 3-point data, meaning that, as you can see here, I'm drawing it on the ground plane, but should I lock upwards and then head back down again, this shape here, although appearing to be 2D, when I look at it in a side view, is actually 3D, as the plane moves up to meet that point and then come back down again. As I rotate around it, you'll also notice that the surface is 3D. Just briefly jumping into a rendered mode, which we'll discuss later on, you can see that this surface has in fact gone up and met the corner of that box. We'll discuss rendering a lot more in lessons 4 and 5. The NURBS curve is a mathematical curve that's much like a polyline or a polygon in the 3D world. Basically, it's the same as a 3D polygon, except it follows a mathematical rule to match all of the points. As you can see here, I'm following the exact same path as our previous polygon, the 3D version, but you can see it's just curving out, much like the second mode of the polyline would, passing through each of these points and creating a curve that moves around. The difference with both of these, from the 2D world to the 3D world, is that they have this Z component. And you can see here, as I change this to vertex only mode and flick through the points, that some of these points actually have additional height data included in them, meaning that although this appears 2D on our screen, it actually flexes in the 3D world. Starting afresh, we're going to talk about the 3 objects mentioned here in the 3D toolset that can't generally be created from our 2D objects. They're a special class of objects that people normally need to access quickly, but don't really want to spend the time drawing. Firstly, we have the sphere. It's drawn much similar to the circle tool in that it has 3 modes here: a center outwards mode, a diameter mode, and a 3-point mode. Essentially, it's a left click for the center, draw out the radius, like so, and then you can see as I fly around this object here, it is actually a sphere, a full-on ball, created from that radius. Similarly, the hemisphere tool is exactly the same. Left click, draw out a radius, except you'll notice there's only half of it. You'll notice under the properties of the hemisphere and the sphere some similar data to circles, where you just alter the radius and it gives you the volume and the surface area. Handy details to know if you ever need to calculate paint usage or flooring coverage. The last 3D object that you can't normally create from your basic 2D palette is the cone tool, and it's drawn like this. One click starts the center, asks you for the extrusion height. Let's choose 200 as our extrusion height, and then asks you to define a radius. Once you've done this, you can see we have a cone. In a rendered mode, just to give you a preview, your cone, sphere, and hemisphere. The cone has 2 property fields, a radius, and a height. It also has another drawing style, which allows you to do a 3-point mode of drawing out the radius and then doing the extrusion up. Fillet and chamfer tools are here as well, quite similar to the ones mentioned up here. I'm going to set up an environment where we can test those out. Just going to draw blocks here on the 2D plane. Using my push-pull, going to lift it out of the ground, make it a bit longer as well. It's looking pretty good. There we go. I'm going to use the fillet edge tool here. Ask me to input a radius. I'm going to choose one and see how it looks, of 20, and then ask me to choose an edge. I'd like this edge here. Once you've selected it and it's highlighted in red, click the tick. You can see it's rounded that edge off quite nicely for me. You can continue doing this to any edge, and it will continue to fill it off the edge for you. Quite similarly with the chamfer tool, just a straight edge version. Clicking here, I'll leave it as 20, and it's cut it off quite nicely. To show you again, clicking on a side, ticking the box, and away we go. You can also shift click if you'd like to select multiple sides and do them both at once. I've just gone back a step in time here to when we had our box originally. I'm going to use the shell solid command now. Shell solid's an interesting one. It essentially cuts out the interior of an object to a thickness to make a kind of hollow box in this case. I've got a thickness of 10 here, and as I left click on any of these sides and tick the box, you can see what it does is cull out the inside of that object. In a rendered mode, you can actually see it's made a shell of the object with the face that I selected as open. Just note that it won't work on all objects, as the more complex the object is, the more geometry that has to be edited. Lofting is the next tool mentioned here. I'm going to jump over it because I really want to discuss it in lesson 5 when we get onto surfaces and mapping. It's what you use to do things like cloth, waving patterns, mesh backgrounds, all the kind of drapey, clothy objects, I guess you'd say. It's great for also doing grassy landscapes, plotting between surfaces for garden designs and that kind of thing, and sand as well. We're going to come back and discuss it when we get to those kind of things because it needs its own little section. Following on from loft surface, we have extract. Extract's a really interesting one. And I normally only use these two options here, the extract curve and the extract surface, but you can also use the point mode. I'm going to select this curve mode here and choose one of the interior edges, this one here, of our shelled out object. When you select that and it's highlighted in red, if you click the tick here, it'll give you this as a NURBS curve. So it's almost like we pulled the piece of data relating to that particular line and made it into an actual line. Similarly, if I choose the extract mode, put it onto surface and would like, say, this edge here as a surface, tick the box, and it will give that to me as a NURBS surface. You can see here I can actually pull that face away. There we go, and I've got that as a rectangle representation of the edge of that box. So it's really great for pulling data back off something. Just to reiterate, I'm going to try and get this little here. This is the rim of this kind of picture frame box that we've made. If I give that a tick, you can see I should be able to pull that out as a surface. There it is there. So obviously you could use that for making 2D representations of things, making cutouts of objects if you had to make this out of foam core, something like that. The last couple of options here, creating contours, projecting, and analysis, relate to advanced lofts, surfaces, point data, and things that aren't really relevant to us at this point in time. We're going to skip over them and come back to them if we have time at the end of this series. Just before we move on to the final exercise for this session, I just need to talk about a few of the movement, orientation, clipping and cutting things about 3D. So to start with, let's just make a regular old box and a regular old circle. Now I'm going to use these for demonstrations, so I'm going to extrude this one to around, let's say 50. That matches in the zone of what else I've got going on here. We're going to extrude this one to a, let's say 70, similar thing. So there we go. I now have a box and I have a cylinder sitting right here. So let's talk about movement of 3D objects. It's very easy just to move objects around, place them on top of each other, But if you have a look here in a front view, although I've placed these two objects on top of each other, they're in fact intersecting. So how can I, say for example, put this cylinder on top of the box? Well, one way is that I could either grab it up, pick it up here, and plonk it on top. That's one way. Second way is I could change the bot Z here, knowing that this box here is 50, type in 50 there and I'd place it on top. I could also do another thing. If I was sitting here in my plan view, which I got to by pressing 0 on my numpad, or you could have equally got it from the drop down here and selected top plan, having the cylinder selected, I could choose from the modify menu, move, and then move 3D, which operates exactly like our regular move would have, except it gets this extra Z offset. So in here I would type in 50. It would move it from its current position up 50. Clicking OK, and even without going into another view here, I can see this has been moved.
Math? No. I do not believe in math, and I don't think we should encourage it.
Oh, okay, this is a really hard one. There are really two sides to this story. On the one hand, you have math, and then on the other hand, you have, this is like non-math.
All 7-year-olds should have the right to decide for themselves if math is scientific fact.
Math is a theory, and it's not at all what the Bible tells us.
Just a little bit. Adding, not times.
I think that people should try to be as knowledgeable as they can. I think they need to get learned so that, you know, they can make a choice about all of the world things.
Yes, it's math. I'm sorry, is this a joke?
The regular old rotate tool here in this plan view works exactly the same as normal. One click, two click, move around, and in this case duplicate. But what happens when we use the rotate tool in another view? When we go to a front view, you'll notice that we get two extra icons here with the rotate tool. One is for standard rotation mode, and one is alignment rotation mode. Alignment rotation mode means that it orientates in accordance to the plane. Just the same as if we were looking in the top-down view, it rotates in the same order. The mode that you want most of the time is the standard mode, which means that it rotates in the plane that you're currently looking at. For example, if I want to rotate this 90 degrees, I'll click once here on the left-hand corner, draw an extension line same as normal, and then rotate around. And as you can see here, I'm rotating it to the 90 degrees, 180 degrees, back down to another 90 degrees here. I might choose this direction, and let go. And there you go, I've rotated that object around in the plane that I'm currently looking at. The mirror tool works exactly the same as normal in here. One click, two click, and it duplicates in the view that you're currently looking at. So that's worked in both the vertical and the horizontal. So now you know how to move objects by numbers in the 3D world, rotate objects in the 3D world, and mirror in the 3D world. So therefore there's only one more thing before we do this exercise. Just getting rid of all of these, going back to our box with an extrusion, and our cylinder. Two objects here, both extruded, both very similar. I'm going to now place this one midway into this object here. And you can see it's intersecting here. So we know that these two objects, and just briefly going to a rendered mode, are completely intersecting there. You can see this cuts into here. We're going to demonstrate the three principles that we discussed earlier with the 2D tools, adding, subtracting, and intersecting in the 3D world. And I'm going to leave it in this rendered mode, just temporarily. What I'm going to do is show you adding first, which is simply grabbing these two objects, right-clicking, or going to your Model menu, and choosing Add Solids. You can see now, it's a solid addition up here in the top right-hand corner. And if I try and grab onto this object, I move the objects as one. They're physically joined as one object. Going backwards here in time, back to when they were two extrudes. Now we're going to choose a different option. From the Model menu, Subtract Solids. Unlike the 2D world, in this orientation we don't actually know which one's on top. It could be the top one in terms of the Z value, but Vectorworks wants to make sure. it'll give you this dialog box which says select object, and this is the object that's being cut into. So in this case I want to cut the cylinder from the cube. So I've got the cube highlighted here in red. I can flick between them with these arrow keys. When you're happy with the one you want to cut into, click OK. That disappears and you can see we've taken a chunk out of that cube in the shape of the cylinder. Going back in time once more, where I've got two extrudes back, I drop down the model menu and choose intersect solids, and it leaves me the remainder, the intersection of the two, where our cube met our cylinder. With any of these you can actually double click on the object, and what that does is take you into this. You'll see a giant orange border coming around your drawing, and it takes you back in time, but it's not actually altering your drawing yet. It's just showing you the operation before that created this object. So you can see here I've got my two objects back. Let's say I do a slight alteration here and move this to the other side. Just making sure that that's going to intersect again. Looking at it in the front view, and that's clipping into it nicely there. Now if I click this button here that says exit solid intersection, or whatever operation you might have done, it's as if it applies this again. So you're going back through the tree of creation. So as if I'd done this first and then done this operation, and you'll notice that's the new intersection that we've been given, where the two objects were melded together. So that's really good if you do something, want to go back and make changes far on down the track. You can go back through all the layers of creation and have a look at these objects again. So now that we've done this, you're ready to approach the exercise coming up. It's quite a long one and it comes in many difficulties. Have a go at what you think you can handle and then work your way up, all the way through until you get to the end. The following series of drawings are an excerpt from Jim Clark's Engineering 102 Materials class. Approach them in order and see how far you can get. This exercise is great in terms of drafting to scale, learning which objects to combine, remove, cull, intersect, add, subtract in order to create each object. See how far you can get and I challenge you to complete them all. Good luck. Once again, I'm James Russell. This is Vectorworks 2013 2A Design class. This is episode 2. Stay tuned for the episode 2 solution video, and of course episode 3 coming up soon. If you need to contact me, here are my details, and until next time, good luck!